Good afternoon and welcome to today's webinar on root cause analysis. This is the fourth session in our 8-part series titled Using Lean Six Sigma Black Belt Skills Outside of Lean Six Sigma Projects. Before I turn it over to Rick Haynes, I'll go through a few housekeeping items. This webinar is planned for 1 hour. If you have a lot of questions, we may go over, but the content will stay within 1 hour. We have muted the lines for participants, so please submit your questions through the GoToWebinar software. As we've done in the previous webinars to the series, we address questions throughout and at the end. So as you think of them, please submit your questions through the text box. There will be a recording of this webinar. It will be available within 48 hours, and you will receive an email with access to this. You will also receive an email with a copy of the slides for future reference. Please know that someone may contact you as a follow-up. You have the option to opt out of this at the exit webinar, so just notify us if you do not want to be contacted by Smarter Solutions. I think that's it. You all are familiar with Rick Haynes, who will be presenting for us again today, so I will now turn it over. Thank you.
Well, hello everybody. We're back again for number 4. I'm going to try to do this one a little bit different because I like to mix it up a little bit. We're actually going to have a demonstration of these root cause tools towards the end, using a little toy I have as a tablet to do entry on a whiteboard software. But again, now this one, the corrective action efforts, or root cause analysis, generally isn't seen as part of a Lean Six Sigma program. And I think as we walk down this list of 8 topics, it's probably one that's the most away from the Lean Six Sigma topics. So here, let's jump into it. Before we dive into it, I'm going to call RCA as a root cause analysis. You may consider that cause and corrective action analysis within your organization. But I would like to know where your organization sits. Now, when you have a cause and corrective action or root cause analysis, this is for question 1, do the problems never return, as in most of them? Or does it work for a while but problems seem to come back? Or there's little success, but it feels good and we're done, or you have no idea what happened. So if Mallory, you'd set the question up there. And if you guys would please answer. Looks like we got a clear lead right now that the works, but problems seem to come back. Well, we're racing up there. Okay, Mallory, I think that's probably close if you'd closed off here. What it turns out is it works for a while and doesn't come back, or they do come back at times. I could guess that that's generally a issue with Lean Six Sigma projects and Lean projects too if you don't close it with a good control plan. But tell us about where we are. There'll be another question coming up about how you guys do your own root cause analysis. But let's walk into the topic here. At the end of this webinar, I'm hoping you'll be able to describe how root cause analysis fits into the overall business improvement, talk about how it relates to continuous improvement, Lean Six Sigma, and we're going to describe and walk through a basic root cause analysis method in this webinar. Before I dive into it, let's talk about how they all fit together. Generally, when I address a problem, I consider it's one of 3 things. It's a special cause event, it's a common cause event, or it's some minor issue that's a nuisance. You can live with it, but you'd like it to be better. Now, this is a great way to look at it, but most of the time you don't know where it is when you start the problem. You're given a project or you've been chasing after something. So some of this you figure out along the way. Now, why I care is I then translate those terms into the most efficient tool. For special cause events, something breaks, something fails, something makes a mistake, root cause analysis is probably the most effective method. Any one of them will get you there for those type of events. Now, common cause events, where it's within the capability of the process, they're just bad sometimes and good most of the time. Generally, the Lean and the Six Sigma methods are your best tools. They are most effective for those type of things. And then for the minor nuisance ones, like you dig into it, realize it's really a minor issue, but it's happening all the time, and it'd be nice to get rid of it, but you're not, say, causing defectives or not getting bad marks from your customers, I would recommend the PDSA, or Plan, Do, Study Act. Some people call it Plan, Do, Check Act, the Shewhart cycle or Deming cycle, but really it's continuous improvement. I've done it a number of times in projects. It's a control plan, but also if it's a minor issue and set around a project, you give the work group the tools to do the little improvements they can incrementally get there on their own. This is a good tool. Now here I had some fun preparing for this, trying to put my vision of the last two slides in a graphic. Because it's hard to make graphics sometimes. So we talk about it, that circle that you see is all the existing problems your business has. There's a lot of things you can do. The first one would be Six Sigma methods. Now you could make an argument that Six Sigma would cover more of the whole than I drew here, but I drew about 60% of the business problems can be very effectively addressed with Six Sigma methods. Now if I add Lean in here, Lean and Six Sigma have a large overlap, but there are areas that you do much that Six Sigma can't handle, Lean can. There's also Six Sigma tools that do things that you can't do within the Lean tool set. And that's, I think, why we're seeing most people go to Lean Six Sigma, but there's still this big piece of the pie over there. What do we do with it? Generally, those are the special cause events that you can't chase with the Six Sigma tools. And in our view here, that's where root cause analysis or cause and corrective action efforts work. And again, they overlap with the Lean and the Six Sigma also, because you can use those sometimes in these events, but not always. So really, all the tools blend you into a complete business improvement person. And again, as Mallory said, if you have questions on anything I'm doing, or even if it's a divergent thought you want to share with us, please just type it on the interface, and we will get to them, because it makes it more of a discussion than just me talking. All right? In the center of the circle goes PDSA. The continuous improvement methods work on any type of problem because it's about a bunch of small incremental improvements. There's very little risk in these methods. They're just relatively slow, but it works on everything. So there's the whole picture. Now, if you accept my view that I just shared, it may help understand some of the difficulties you may have seen in business improvement. You may have found Lean by itself is not enough. Now, if you read a Lean book, it'll say you can approach any problem with it, but I bet you've seen that some problems are less effective in working with these tools. Same with Six Sigma. There's some problems, yeah, you can run a project, but it isn't a very effective way to get working. Root cause analysis by itself alone is not enough. Most businesses, this is their primary business improvement tool. Whenever there's a mistake or problem, they do a cause and corrective action or root cause analysis, come up with a plan, implement it, and hope the problem never comes back. Now, it's a robust tool when you've just got things going wrong and mistakes and breakage, but it's not as effective as you'd expect it in many cases. But if you look at the continuous improvement piece, the PDSA, I believe it's effective on any type of problem out there as long as you are willing to accept slow incremental change. All right? Now, as a black belt, you should have been trained in Lean. You should have been trained in Six Sigma. Chances are, the better programs, you also got trained in the continuous improvement cycle, whether you realized it or not, the PDSA. But it seems that root cause analysis is just not included. Or is it? And I guess that's part of what this webinar is about, showing you how you got pieces in your black belt training that you can use for root cause analysis. There's many methods available. They all start with a similar belief. And it's not that there's a root cause, surprise, and I'll address that in a minute. But the belief is that the process you're examining has a deterministic nature. In other words, it's got clear cause and effects like problems or switches. When this occurs, that output always occurs. So that you, by starting with that paradigm, when a problem existed on Tuesday, if I look at everything that was happening on Tuesday, there was something that occurred on Tuesday that didn't on Wednesday or Monday that caused the problem to occur. And whether you think about it or understand it, that really is the basis for all this root cause or cause and corrective action results. All right? But put those words into our Lean Six Sigma words, you're talking about a special cause event. Now I'm going to talk about two simple methods. I'll share what my favorites are at the end. But this is a real simple root cause analysis, non-proprietary, non-third party. This is just traditional stuff. We'll talk to tree diagrams and switch theory. I've never really seen switch theory in a book anywhere, but I learned it from one of my mentors years ago, and you'll see how these two fit together for doing root cause analysis. All right. We'll start with tree diagrams. Now, you may have heard these as fault tree diagrams or why diagrams when you learned your Lean Six Sigma training. Now, what do you do with them? It really is a method in projects to replace the brainstorming step in some cases, where you list your problem at the top and you say, what could have caused it? Why did it happen? That's the first set of branches. Okay? Those are causes for your problem. But you have to remember that each cause can be considered the effect of a prior cause. So that's your next branch in every tree. Every cause could have things that caused it. We'll show an example in a minute. But again, you keep moving. I generally do the problem on the left and the branches going to the right, mostly because I present them. If you're doing it on paper, it's almost better top to bottom. But what you end up doing is everything on the right-hand end of a branch is your potential causes. All right? Now, these tools work best when you've got a system that's very well understood. In other words, all the causations are generally known. There's a finite set of known causes, so it's not an infinite thing. I mean, you wouldn't consider a meteor hitting the power pole is a reason you lost power. But it really is extremely effective when you have a true special cause event. Now, here I'm talking about using the tree diagram for root cause analysis, not as a brainstorming substitute, and it works there. Where does it not work? When you really don't understand your system. There's no real causal relationships known. Or maybe there's so many potential causes, you can't deal with them. And the last one to throw in the statistics, if it's a common cause-based problem, you will never, quote, never, 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 never find it with root cause analysis. Because whatever's causing it existed probably on both days, just today it was bad, yesterday it wasn't. So that's a big one. And what I mean by common cause is the problem, the error, the mistake, the scrap is within the capability of the process. So here's our next question. Before I dive into the switch theory and we do an exercise, your organization, I got to believe they do root cause analysis or cause and corrective actions or whatever you may want to call them. But I'm wondering what your organization uses. Do you use one from a third party, a licensed system to use? Do you have an internally developed program with sheets and rules? Or is it just the leader does what the leader wants of the effort? And then the last choice is, I don't know. Well, thank you for answering. Keep plugging them in here. Interesting, it looks like the leader is in charge, is the winner right now. If you'd close it up, Mallory, that'd be great. Look at the polls there. Most people have the leader chooses the method. Now think about it. Does that make sense? We spend all this training for Lean Six Sigma. We have all these structured things going on. But when we have a true problem, we're going to go address it. We just do whatever we want. It doesn't make sense. So I end up talking with most of the organizations I consult with when I realize that they don't have a system, that it's worth either developing one internally or bringing one in from the outside. It can be very beneficial to have a consistent method, because when you have a systematic method to do something, you're more apt to be successful in a short period of time. You're also not as dependent on getting a good person to lead it. So I hope your organizations get the view of moving towards either internally or developed or a third party. Let's take the next one. You may or may not have heard of it, called a switch theory. It really is a bit of an extension of the idea of the tree diagram. You really sort of take your tree, your fault tree, which is really an interrelationship of causes and effects. You follow it to the most probable cause and the most probable effects. You then adjust the tree to say what things had to happen for that cause to make that problem. You'll see as I walk through it how it is a wonderful way to build a control plan, because you can, when you do it, you treat it like an electrical circuit, making a light go on when the whole set of problems go wrong. Here's a little diagram at the bottom of this. As you see, you can have 5 causes that you've identified. And we treated the switch, if the cause exists, the switch closes. Now, if you look in this diagram here, cause 2 and cause 5, if either one of them exists, the problem can occur. But for 1, 3, and 4, if that cause isn't there, it does not matter what the rest of them do, the problem won't occur. Now, if you look at the picture, you realize we've made a big jump from cause and effect. We're taking the assumption that's really a combination of things must align for the problem to occur. I'll talk a little bit about my favorites, Apollo root cause, coming up, but they talk about conditions and the actions must both line up sometimes to make the problem occur. Now, I'm assuming most of you haven't seen this view of it, so what we're going to do is when I get done talking about these 2 pieces, we're going to slowly walk through one about your car doesn't start. Hopefully you all have a car and you'll understand that you go through this process, but cars are a pretty known deterministic piece of equipment. The neat thing about the switch theory, though, is what you end up, if you look back at those diagrams, you can see which of the causes have more of an impact on you if you put a control system on them. Like if you remember that one, 2 and 5, if either one of them went wrong, you could make a problem. But with 1, 3, and 4, if you fixed that and completely eliminated that cause from ever occurring, it wouldn't matter what the rest of them are doing. And the whole idea of the rest of them, no, I'm going to backtrack again, but this is one of the problems with general root cause analysis. I'm going to go back a slide. But let's say cause 2 is coming and going, cause 5 is coming and going, so is cause 1. The other 2 don't happen. So 1, 2, and 5 are happening. Whereas the only time the problem occurs is when you get a circuit through 1 and 2 or 1 and 5. So really, if you looked, every time 1 might be closed, the cause 1 might exist, the problem occurs, but you'd never find cause 2 and cause 5 because it could be there today and not there tomorrow because 5 is, and you miss that combinatorial failure. And that's what's neat about diagramming the switch up. And I think this is a tool, when I learned it, made my cause and corrective action efforts more successful in the fact that they truly eliminated the problem. They didn't get what you folks put on your poll, that generally you fix stuff, but they come back again. Now here's one of my favorite discussions on root cause. Are there really root causes? I think when I took one of my courses, we got all done and I asked the instructor, why do you call this root cause analysis? Because you told us throughout the class that there isn't a root cause. It's always a combination of things going on. And he goes, yeah, you're right. But when people take a course in this, they expect it to be called root cause analysis, so we use the title. And it turns out all of them do. And we talk about root causes, but there really isn't. Because generally, multiple things have to occur before the problem exists. Now, if that's true, there isn't a root cause that if I remove one thing, everything gets better. All right, so that's a little aside there. Now, since this is this webinar series about using your black belt skills outside of projects, I decided, like this one, treat this topic a little different than the last. We're going to walk through a DMAIC on an example, and then I'm going to do one on the screen for you. But what's the define about? It is to verify that you have a real problem in front of the organization, that you have measured it, you can confirm it, it's real. Now, the second one, you can verify that the requirements are really violated. Because I'll tell you, I've chased some down to find out that they were perceived and not real problems. A client recently had that. They got down there and realized that it isn't a problem. It was people were marking it down on a problem sheet as the biggest issue, but it turned out it was easy. It was the first one on the list. People just picked it. So again, sometimes the data that you chase after isn't right. The next, so once we've got we've defined a valid business problem, the next is collect performance data. Now, we need to do that for root cause analysis, just like we do for projects. So go get performance data. Generally, this is the output data that you detected the problem with. All right. Use a control chart to see if it's common or special cause events. Because if you see a special cause, you're going to treat it with root cause analysis. Now, I can see cases where somebody got hurt because a piece of equipment broke and it sprayed chemicals on somebody, or like if you were in Austin today, it rained, flooding came in and damaged the equipment. You really don't have to collect a lot of data on that one, but sometimes you do, especially when you get a whole lot of material, or one whole customer's claims all got rejected for some reason. You have to go understand what's going on. So once I get that, the next one is collecting potential causes. Now, we can use brainstorming, cause and effect diagrams, or whatever. But in absence of anything, you start out with your corrective action team and say, what could have caused it? Make the list, just like we would for a project. Then I get to analyze. Now, there isn't a lot of statistics in this one, but for analyze, recommend putting it in this tree diagram. What we're doing now is we're starting to take our causes and treat them hierarchy. Oh, I messed around. In order. I can't pronounce that word today. In a hierarchy. So you have some come before the others, and we start putting this plan together to say it's not just one cause, one effect. We start seeing the whole idea of sequence and combinations. Now, what we do is we work down from the problem on the left, I'm going to talk about left to right, to causes on the right. Every time you put a cause to get that effect, you say, what cause could have come to make that cause now an effect? We build the entire tree up. Now, once we've got the tree built up, then we start doing our analysis of which was the most probable branch or path that caused our problem. So we take it, follow branches. Now, one thing I think you should do is the same thing we do in Lean Six Sigma, is collect evidence for each causal event that exists there. If you say your car didn't start because you have a bad battery, what's the proof of that? Or the evidence? Well, clearly if there's no electricity, the starter can't turn and the ignition can't go. So you write down the case that shows that relationship or that causation. This is done so the next person behind you can follow your logic, but it also helps to explain it to people that weren't in the team. All right? Look at all your branches. You can read it there. The next step after we analyze, now this is where we get to the switches. Now once I've followed all those branches, say these are the most probable branches that could have led to my car not starting, or a series of claims failing, or even a software that start having it's failing or crashing, because you're looking at all the different things you do. You're going to then take that knowledge and diagram it in the switch pattern that we talked about. Create a switch for every condition, action, or behavior that would allow the bad effect to go on. Then you examine each switch for your ability to control it. Once I've built all my dependencies with series and parallel switches, you can find the most effective ones to put your control system on, because you really do not have to control all causes. You have to control a minimum number of causes so the problem won't occur. And that's the neat part of this. You don't end up like a Kaizen event that you got 25 different things that could have done it, and you fix all of them. By adding this piece in there, you come up with a limited set that's very powerful. Control, just like you'd do in a project. You have to create a control plan to manage the switches. Okay? You may examine the remainder of the tree that was not in your direct causal effect and find a serious one that's at risk. Choose to control that too. I guess that would be analogous to an FMEA, always addressing the high severity issues even if they were quite improbable. Because what you're looking for in this tree diagram is the key causes or events that if I can eliminate that, a whole series of branches now cannot exist. It's also a neat thing to provide the tree diagram to the process owner, so you've almost given them a troubleshooting guide now to manage their process. It's quite powerful. Okay. If you have any questions, it's been a bit quiet, probably because you're so fully engaged with this topic. I mean, I'll probably live with that one. But we're going to walk through an example of my car does not start. Why did I pick this one? Well, because I had to go through that with a friend just this week, and it was fresh on my mind. So let's start it. I'm going to go switch to another software package that gives me a little whiteboard to work on. Here it is. My car doesn't start. You were chartered to go solve this problem. Now, your only symptom they gave you is it looks like the starter turns, but the car does not start. All right? So what are potential causes? I think I'll choose to type here instead of, all right? All right, one is dead battery. Well, no, that wouldn't work, would it? Because starter wouldn't turn. But that still is a potential cause of not starting. Like all brainstorming, we won't throw it out. How about a weak battery? That might work. It can turn but not enough to start the car. You'd say bad plugs, no gas, no spark. You can list a bunch of things that could cause it, but we'll go there. There's my potential causes. They're going to have a little bit more, but now how do we put that into a tree diagram? Now this is where we'd start. All right. Let me take those for starters. I'm going to move them over to creating my tree. So I got them down here. Let's build a tree now. Car did not start. This is going to be a little rough. And by the way, you'll get a copy of all this. Not start. All right. What are the potential causes? Well, I would probably draw this up knowing more than the simple one. When we can have the starter spins, starter but no ignition. Well, I can't spell either. You can have no starter. Right? That's about it. So let's start my tree here. I got there, and I got there. Now, what's a starter but no ignition? Well, this could be no gas, right? I got no gas on there. It could be bad plugs. Could be bad wires, the spark plug wires. What else can cause it? Oh, no electricity, no power to ignition. Okay. Now what can cause no gas? Well, forgot to fill up. There's other ones. Leak. Probably have never had them, but I've had a leak in a gas tank before in a gas line. You can also have an air bubble in your line. There's another one. Failed fuel pump. Now I'm going to change this one. What we have here is, so you can play with these things. This is no gas to engine. Now this can come from bubble in fuel. Now if you ever had it, you can get a little vapor bubble in your fuel pump and it won't pump fuel. Pump failed. You can also have a plugged fuel filter. And I'll start with that. So with no starter, I'll go down here. We can have motor failed, wires to it fail. We can also have a solenoid failure. By the way, I can't spell, so you're going to have to live with that. How can the motor fail? How can the wires fail? We'll probably stop this. Let's draw a couple lines here in our tree diagram. These turn out different every time you do them. I'm going to show you a completed one that I didn't spend as much. I spent a little more thought into it. But I want to get the point here. These can be free form. I'm getting rid of air bubble there because I have it over here. So here's a simple tree. Now, how would you do this in real life? Just like we're doing here. You just draw them up. You could do it on a whiteboard. You could do it anywhere. But there's a little tree diagram. I got all my potential causes, but while I was doing this, like brainstorming, you come up with some additional causes. I hope you realize, and maybe you did or didn't, it'd be interesting if you never saw this diagram as part of your Lean Six Sigma training. It'd be nice if you just sent a note in, because I think it's covered in most of the good programs. Isn't it potential replacement to brainstorming. All right, so there we have it. Now I have a completed one on the next piece here. Hope you can read it. It's probably a little small on your screen, but I went through all the things that cause your car won't start beyond the one that the starter's spinning. But you can walk through this, and it really, if you think about it, it's really a troubleshooting guide at some level. You can walk through the end. Now you treat it, everything on the far right is a potential cause. All right? And this list is longer the more problems you've had within the area, the more history or knowledge your subject matter expert may have. But now I've got my tree diagram done freehand, but it tells me a lot. Now I'm starting to see the dependencies. As you can see, if I could make sure the battery didn't fail, all these cease to be issues. And you can start looking the farther up the chain, the closest to where it won't start. Now let's look at the switch theory. I'm not going to really diagram this one for us on the screen by hand because it's too hard freeform to do it. But here I did one for the part that's our existing here. We start off with, I should have a little highlighter pen in here, I think. We start out with everything's good. Now, we're going to end up with 2. Starter runs, but car does not start. Now, if we take our causes on the prior slide, what can they be? Now, let's talk about them in sequence. But generally, you go backwards. Your causes come here. So I could have, there's a bubble in the fuel. There's one that we had. I could have just run out of gas. I could have had bad wires, bad plugs, and a fuel filter clogged. These are the ones, if I go back, the ones we created here. That's these 3 that lead to no gas to the engine. Here we've got the plugs and wires to no starter. Okay. So I've got prior causes, but let's look at this one. Now, if you've never seen this, it does happen. You have a vapor bubble in the fuel caused by engine overheating. A lot of times if your engine overheats and you park your car, what happens is it heats up in the engine compartment, it'll make a little bubble, and if that bubble gets to your fuel pump, it can't pump vapor. So if the engine overheats, I can get a vapor bubble. I can be out of gas. But how can these be issues? Well, I also must not be checking my gauges routinely in the car because you don't overheat and not see it, but also you should never run out of gas without seeing it. Now, I could put an extra switch in here that says I'm out of gas because I was in. Why are you out of gas? I'm in a hurry and I forgot to check. My gauge doesn't work. My son drove the car last. You can put in more and more of these switches, but they relate back to, if I can fix this one, all these go away. Now, if you don't realize, that's why they put warning lights on, because if you don't check the gauges, or if you don't, I guess if you don't purchase a vehicle that's got gauges, you just have the lights, but they're to do this for you. Now what about this one? Fuel filter, bad plugs, and bad plug wires. Well, they come from, if you don't do regular maintenance, get it performed, you're at a risk in all these because these are replaced with normal maintenance. Now notice how it says here, if I'm going to not check my gauges, the switch closes. What's left? I can get a failure for either one of these now, but I have to be engine overheating to get a bubble, and not always do you get a bubble. But if I'm running out of gas, it's pretty much a sure my starter will turn and my car won't start. But if I don't do regular maintenance, any one of these 3 can cause a failure. But if I did my maintenance, I don't have to worry about those. They're done. Now you can put more and more causes. Now these take a bit to put together, but you start seeing the causes that are furthest to the left, or those switches. If you can fix those with your control plan, the other ones aren't as important anymore, and at some level you can ignore them. Now I would say if this was a lean event and we had all these listed, we would put a improvement in for every one of these. We may change the frequency of plugs. We may also then have an extra one to go work at wires, start pulling, when really all we should have done is just maintenance. So this is the advantage of using the switch theory. And I hope that gave some idea how it works. So I'm going to go back to my presentation. I hope that was a little example of root cause analysis. So I've covered at this point, oh, Mallory?
We have a question that's come in asking why this root cause analysis is left out of most black belt courses?
It's an interesting one. I wonder it myself. I've come to the belief because everybody thinks they do it well. And I think it's also been around forever, just cause and corrective actions, get everybody in a room, list it all up. And people feel good about it, and they assume you have it. I mean, we could make a similar discussion. Why don't they talk about many soft skills, team leadership in black belt courses than they do? They give you a cursory look. If you become a supervisor, you might spend weeks of training just how to lead a team and to mentor and all that. Parts of they assume you have it when you get there. I also believe some of it may be that root cause analysis has been around so long, it's harder to build a intellectual property that makes you special that you can sell for it. There's a handful out there, but that's probably the best reason I got. Thank you for that, Mallory. Now, my personal preferences. I've probably been to 3 or 4 different systems in my life through my different employers, but my favorite, and I'm pitching for a company that we're not getting anything from, there's no business arrangement with them, but it's called Apollo Root Cause Analysis. I like it because they use a tree diagram, but they say every cause generally has a corresponding condition that must have existed for that event to occur. And they really spend a lot of time on documenting why you are sure that when this event and condition exist, that your bad result will occur. And I think that's why I like it the most. It's very methodical. It's very easy to understand. If you've been around, you can just get their little book and teach yourself pretty much. But it is used widely across the world. It's a very good one to learn. I like it. So I guess I'm partial to that. But it is clearly not the only one out there. Kempner-Trago is a very popular, they call it rational problem solving, but at some level it's root cause analysis. There's a lot of them out there. All right? Now what's the problems? Because I made it sound real rosy, and it really isn't super easy. There are problems. And the biggest one that comes up is the same one we fight in our Lean Six Sigma projects. Just because an event occurred at the same time as the problem does not determine causation. When I'm teaching Lean Six Sigma and regression and ANOVA, just because you have a low p-value does not mean there's causation. You have to do that yourself. That's why people are involved in this process and not a computer. I mean, you probably have heard the ones about storks. More storks bring more babies, so storks must be part of the birthing process. Because they did a study in Europe, they saw that the stork population was increasing exactly with the birth rate increasing in Europe. So does that mean that they're related? And no, it just turns out when families are created, they get single-family homes that had chimneys, which were roosting places for storks. So the causation was the family home, not the arrival of a child. And another favorite one is there's ice cream causes crime. Because as soon as they start selling more ice cream in Chicago, the crime rate starts to go up. So therefore, you should ban ice cream sales to reduce the crime rate. Well, of course, if you've been to Chicago in the winter, you know why there's not much crime? Because it's too darn cold. Even the criminals don't like it. So again, ice cream sales go up as it warms up, but so do people go outside for crime. So causation does not mean correlation. So even with root cause analysis, it's probably more difficult to tell because we don't have the data to look at. A lot of it's opinion and belief. Next one, most people only analyze when the problem existed, and maybe just prior to it or just after. But by doing that, you can see a whole bunch of things that occurred, and it could be Joe was running the machine at the time. So it's the only thing that seems to change because yesterday Joe was on vacation, so Joe must be the cause. But you understand, if you don't look at the whole system, at some level we call a project in a baseline performance assessment, you may not be realizing that what that cause that you were really ready to change has been occurring all month, but it didn't cause the defect or the problem until today. So if it could happen 5 times in the last 2 weeks and today it's a problem, it wasn't the other 5, I'd be worried that it is a correlated event, not a causal event. And the last one here is, this slide is people don't test their conclusion. Now, if we were in a Lean Six Sigma project, you always do a validation or verification of your improvement. Generally, people don't go back and root cause analysis and make sure that they have fixed it. And the last one, even if you find a true cause, if you don't put a control plan together, you haven't really avoided its reoccurrence. You haven't done your job. I laugh at a lot of places I go to, even the last place I worked, that I was struggling to get it done. But every cause and corrective action effort, the control plan or the actions I could have written before it started. We disqualified the employee, sent them back to training. We lectured the entire group on the problem, and we changed the process instructions to tell them, don't do that again. I mean, I said the site for 3 years at a site out in Idaho, and I swear that's what they put on every single one of them. It didn't work, but it was easy. They found that the customer would accept it. Let's just do it. So unless you do a true control plan, you're probably at risk. But that wraps up the content for today's talk. Did I cover the topics I said? Do you see how it fits into the overall business improvement system? Can you describe the differences of root cause analysis, Lean Six Sigma, or Lean and Six Sigma, and the continuous improvement, to understand that if you address a problem, there's sometimes more effective tools for it. And I hope you can get an understanding for the basic root cause analysis I talked about, the tree diagram and the switches. All right. Again, questions if you have them. Mallory?
Okay. How can I get involved in root cause analysis efforts at work?
All right. That's a good one. Generally, the leader for root cause analysis is the process owner or his manager or leader that runs the effort. Volunteer. If we talk about the last 3 seminars, you volunteer to get involved. You will find that your skills in managing a project are sought after in almost any one of these events. Just get in there, give suggestions, offer to take the minutes from the meeting, force them to be methodical, ask questions. How do we know? What can we do to show that we know that that's the cause? Did it happen last month, and do we have the same problem? But if you ask leading questions, they'll keep you on the team because they'll get better. They may get frustrated because you can't. You're less able to go with belief. But I'd say it's volunteer. Talk to somebody who's senior and say you'd like to get involved in the root cause analysis. In my history, nobody wants to be on those efforts, and they're always willing to take somebody in to help. Because most of them, if you've got an, I'd say uninformed or a backwards, I mean, not like any of those words, but if your cause and corrective action efforts are the only blame fest, we are going to make a decision on who to blame for the problem, nobody's happy with them. I mean, I've had somebody had to present evidence like a court case on what went on, what were you doing, and they were just looking to castigate people because they didn't follow the procedure, they didn't do this little step. And if you're doing one of those witch hunts, they are not fun. So sometimes just taking these tools we talked about today can make it friendly again. All right. Thank you for that. Mallory?
And someone else asked, why not just use the Six Sigma tools?
Yeah, I talked about that a little bit earlier. Now, I can understand why you'd want to. Why you'd want to, because everybody, when it gets tough, falls back to things they know. And if you get a real special cause event and you say, well, I'm a Six Sigma guy and I'm going to start using those tools, what you'll find is you'll work really hard, but you can't confirm your answers because special cause events happen and are gone, and most Six Sigma tools don't look at them. So I'd say you can in some cases, and that's why we talk about really define the problem, do a baseline of it in the measure phase to determine what is the best tool. Now, you may go after it with Lean Six Sigma. You also may choose to a point and say, you know, I'm not the best one for this. Let's find somebody else or ask permission to change the tool set. But I don't recommend it just go, you know, what's one of the phrase? If the only tool you have is a hammer, everything looks like a nail. I really want you to get beyond that when you leave the Six Sigma genre. You can't look at everything as a project. It's probably one of the things that Lean Six Sigma gets hit on the most, is every time I say a problem, you want to start a project and make a team. You don't always need that. And that's probably part of it. So I went around it That's all I have right now. Anything else, Mallory?
How does the tree approach mesh with CTQ flowdown? Are these the same, complementary, or different?
In a graphical representation, they're very close because you start with the top and move down in the tree. Probably the difference, I'd say, is the purpose. I'm going to define what I see as the CTQ, which would be critical to quality metrics. Generally, when I hear the flow down term, the business has set a overall organizational quality measure or performance measure. And what you do is you roll it out to what piece does every part of the organization, every function have to doing it. Now, sometimes you don't. HR doesn't have much to do with quality, so they may not get a flow down to it, but some do. Now, yeah, the diagram works the same, but I think the difference is we're not talking about causation. We're just, how about disaggregating the overall metric? We're breaking up into pieces. It is done more in scorecards like that, but in this case, I mean, it looks the same, but I think we treat it different because we're really asking why this causes that effect, and it is really a point-to-point comparison. So similarities, but not exact. All right, that looks to be our last question. I really appreciate you listening. I hope we're still meeting your needs. There will be an exit survey at the end. Please fill it out. I enjoy reading those. You guys have given me some good comments and plus also some for areas of improvement. Let me perform the PDFA on these webinars, and they will get better every time. All right. Thank you very much.